Vanakkam. Hi, hello everybody. This is Dr. Jayali Lasita. Today I am going to solve this problem 3.46 from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. So this is meant for beginners only. So I am dealing this using 5-page concept. So in the first page or we'll be reading and inspecting the problem, and in the second page we will be analyzing it, and in the third page we will be forming the equations. We will be solving that particular equations in fourth page, and in the fifth page we will summarize the answers. Okay, let's get started. So this is our first page. First we have to read or inspect this particular problem. We should understand what are all the elements present here. We start from here. So this is 12 volts independent voltage source. Here we have three resistors, 3 ohm resistance, 6 ohm resistance, and then 8 ohm resistance. And then here you have this another voltage source. But the thing is 2 V naught, right? Dependent voltage source. The second thing is markings given. So if you look at this, here this polarity is given plus minus. First one polarity of voltage source, and I can take this as voltage sources because here also this polarity is given, it is marked as plus and minus. Good. Second thing, here also this polarity is marked. So for V naught polarity is marked. And see here we have this loop currents I1 and I2 are given, they are marked. In some problem they won't be given, here it is marked. Okay, so loop currents I1 and I2 are marked. So in this problem when you read or inspect, we understand that some elements are present, some markings are also given. Now we move on to the next page. So what is the next page? It is analyzing. So while analyzing only we'll come to understand actually how to solve this, what are all available, what are yet to be marked, like that. Okay, and we'll come to some kind of inference and all. So here we understand that two loops are present. So from that we come to the conclusion, or we come to the inference. We can use Kirchoff's voltage law. So if it is Kirchoff's voltage law, we must write mesh equation or the loop equation. And when you go for this mesh equations, definitely we have to apply Ohm's law. So what is Ohm's law? We know that V is equal to IR. This formula is to be applied. And we understand that here the variables are I1 and I2. These are the variables, okay? And which are need to be found out. Since we have two loops, we have to form two equations. I told you that we are going to write KVL. KVL is nothing but writing voltage equations. You should understand that. So we have to form the voltage equation. When you write this voltage equations, we need to mark the polarities of current flow through the resistance. Okay, so it is, suppose this R3 ohms is given. So when the current is flowing in this direction, suppose this I1 is flowing, here you have to mark this is plus, and here it should be marked this is minus. So for this it would be plus minus for the I1. Through this it is plus minus. That is, this is the entering point of the current and this is the leaving point. Okay. Similarly, one more thing we have to analyze. This 8 ohm resistance is common. It is a common resistor. So for this, through this common resistor, we write two loop equations. So when you write equation 1 for this loop 1, how do you write this 8? That is, we are writing actually voltage equations, isn't it? Voltage is I into R. First actually we are writing this resistance value, then we'll mark this current. Okay, so 8 multiplied by this I1 current is flowing downwards here. So this is the entering point and leaving point. At the same time, this I2 is flowing in the opposite direction, upwards. So we have to mark this like this. This is I1 minus I2 for the common resistor in loop 1. The same thing actually differs when you go for this second loop equation. So when you write the second loop equation, so when you write this loop 2, what happens? This is the common resistor. The current I2 is entering in this direction, so this is plus entering point, this is leaving point. At the same time, this I1 is flowing downwards, isn't it? So for that case, we'll be writing the voltage equation as 8 into this I2 minus I1, like that we have to, okay? So this is the way how we are writing the voltage equation for this common resistor. So finally, I have to tell you about KVL. So what is KVL? KVL is Kirchoff's voltage law. So if you want to mention it mathematically, then simply I can write it as it is the summation of the voltages in a closed loop or a closed path is equal to 0. So if you want to give it in the statement form, the summation of the voltages present in a closed loop or a closed path is equal to 0. So in other words, we can state it as summation of voltage sources is equal to summation of voltage drops. So this voltage source or the available voltage sources, what is this voltage drop? Voltage drop is the drop across the resistors. Okay, across the resistors, the voltages will be considered as the drops while the current is flowing. So now we move on to third page, that is forming equations. So we know that we have two equations. One corresponds to loop 1 and another one corresponds to loop 2. So this is our loop 1. So this loop 1 starts here and we traverse through this path, this one, and then this one, and then this one. Okay, so we start here. So when we traverse through this path, we encounter with this 12 volt voltage source and its starting point is minus. So we need to mark this as minus 12. So it is nothing but using Kirchoff's voltage law, we are writing the voltage equation. Then we traverse through this 3 ohm resistance. So what is the voltage available here and what is the polarity encountered first? This is the plus sign. So we need to write this as plus V naught. Then we are traversing through this path which consists of this 8 ohm resistance, which is a common resistor for first loop and the second loop. And let us mark this voltage as V1. And the entering point here is this one, so it is plus and minus. So this should be marked by us. So I am going to now write this voltage across this 8 ohm resistance as V1. And then we are now traversing through this common path where no element is present. So with this, the number of voltage sources and voltage drops are over and this is equal to 0. So we frame this voltage equation. But to this voltage equation, we need to apply Ohm's law wherever necessary. Ohm's law is nothing but V is equal to IR formula, isn't it? So I value here is the current I1 is flowing through this particular loop. So it is I1. What is the resistance value? It is 3. So V0 is equal to 3I1. So this is what we need to substitute now. Okay. So minus 12 plus this V0 is 3I1. The next one is V1, right? So V1 is the voltage across this 8 ohm resistance. So what's the current that is flowing? Since it is common to both the loops, I1 current as well as I2 current are flowing. But this I1 current is the one which is actually to be considered first because that corresponds to loop 1. So that I1 current is flowing downwards through this common resistor, that I1 current is flowing downwards. At the same time, this I2 current is flowing upwards. So it is flowing in the opposite direction. So how to write this? That I1 minus that I2 multiplied by that resistance value is 8. So it is 8 into I1 minus I2. Like this we need to write the equation, right, for this V1. So now we can substitute it. So 8 into I1 minus I2, that is equal to 0. So now we elaborate this. So plus 12 plus 3I1 plus 8I1 minus 8I2, that is equal to 0. So it is 11I1 minus 8I2, that is equal to 12. This is our first equation. So now we'll be forming loop 2. So we understand that this is loop 2 for which we are going to write the equation. So as usual, we start from here. This loop starts here and it travels through this path, then this path, and it ends here. And we'll mark the corresponding voltages for this. Let me take the voltage across this 8 ohm resistance as V1 and this is V2. And the current enters at this point and it leaves here, the side 2 current. And here it enters here and leaves here. And already this polarities are given as plus and minus for this 2V0. So when we start from here and traversing through this, we encounter with this plus V1 and through this path. So when you travel through the 6 ohm resistance, it is plus V2, and when you travel through this dependent voltage source, it is plus 2V0, and then we travel through this common path where no element is present, so it is equal to 0. So we have applied KVL and we have written the voltage equation for loop 2. But the second step in this is to apply Ohm's law. So for V1, which is for this 8 ohm resistance, which is a common resistor, and I2 is given preference for this loop 2, we can write the current as I2 minus I1 current, because both the currents are flowing in opposite direction, multiplied by that 8. Here we have applied this I into R, Ohm's law. Okay. So that is equal to 8 times I2 minus I1. So that can be substituted here, 8 into I2 minus I1 plus V2 is the voltage across the 6 ohm resistance. So by applying Ohm's law, what is the current flowing through that one? It is the I2 current. What is the resistance? That is 6 ohm resistance. So it can be written as 6I2. So plus 6I2 plus this 2V0. But when you look into this V0, it is already known to us that it from the first loop itself, V0 is equal to 3I1. So that can be substituted here also. Instead of this V0, we can write it as 3I1. So that is equal to 0. So it is 8I2 minus 8I1 when you multiply this, right? Plus 6I2 plus 6I1, that is equal to 0. So it is 14I2 minus 2I1, that is equal to 0. So when you divide by 2, it becomes 7I2 minus I1, that is equal to 0. Or we can write it as I1 is equal to 7I2. So here we got the second equation number 2. So we have formed two equations already. This is equation number 1 and this is equation number. So now we are moving on to page 4. So what is page 4? It is solving the equations, right? So solving the equations, what is the first equation? Now substitute equation 2 in equation 1. So it is 11 into, instead of I1, you can write it as 7I2 minus 8I2, that is equal to 12. So 77I2 minus 8I2, that is equal to 12. So it is 69I2, that is equal to 12. So what is I2 value? I2 is equal to 12 divided by 69. So that is equal to 0.1739 amperes. So we got one answer for the loop current. So after getting this, you can go for second equation. So what is second equation? I1 is equal to 7 times I2. So in that you can substitute this value of I2. So 7 into I2 values 0.1739 amperes, isn't it? So this is equal to 1.2173 amperes. This is I1. So we got the second answer also. Okay, fine. So in the fourth page, by solving the equations, we got two answers, which are the required answers. So we can summarize this. So the answers are I1 is equal to 1.2173 and this I2 is equal to 0.1739.